So we're up to the last section of chapter 6, and what it really is a combination of complex numbers with the quadratic formula. So it's kind of nice you get a little bit of practice in both before the final test. But 610 is titled Analyzing Solutions to Quadratic Equations. And I want to just get back to, well, what was the point of the quadratic formula? So the quadratic formula finds where the parabola touches the x-axis. If you think about it, if we had a quiz on it, a bunch of you probably got this part wrong, was that really when you take and put a b, and c into the quadratic formula, you need to make sure it equals 0. So for those ones that said find the x values where the height is 80, you had to put an 80 in here and then subtract it from both sides before you started plugging numbers into your quadratic formula. Because really the point is, well, y is 0. When that's the case, what's x? So we have three possible solutions, and you could quick scribble these out if you wanted to, or pause the video and do it. But when you have your parabola, you could get the situation like this one, where you're going to have two x-intercepts. We have one there and one there. It crosses the x-axis twice. Sometimes it's just going to have one. The vertex will be right on the x-axis. And other times you'll have it like this. It doesn't have any x-intercepts. So that's going to be the three possibilities. So two x-intercepts, one x-intercept, or zero x-intercepts. And if we look at our quadratic formula, the negative b plus or minus square root of yada yada yada, how could we get 2 or 1 or 0? And what it really comes down to is this part in here inside the radical, that when we have the plus or minus, when you add a number and then divide by 2a and subtract a number and divide by 2a, you're generally going to get two different solutions, one from adding the radical and one from subtracting the radical. But sometimes it's possible you'll just have one. If what's inside the radical ends up being 0, square root of 0 is 0, you add 0, you subtract 0, you only get one answer. And then the times when you have 0 is going to be when you have square root of a negative number, and you don't have a real solution, you get a complex number solution. So I want to say this discriminant, they call it, determines which one of those three graphs you end up with. So the discriminant technically is the b squared minus 4ac. It's what's inside the radical. I rewrote the quadratic formula here, put the discriminant in red. I want to make the comment, it's not the square root of that. It's not the square root of b squared minus 4ac. That's the most common mistake that I see here on the test and the homework. People will answer the question, what's the discriminant? They'll do the square root. Instead, it's just what number is inside the square root. So thinking back to those three graphs that we had before, we really have three different possibilities for kind of numbers that you could get for a discriminant. And I mentioned that on the last page of notes, but the first thing, b squared minus 4ac, that could be positive. So we're going to write b squared minus 4ac is greater than 0. So that'd be one possibility. Second possibility is going to be b squared minus 4ac. Instead of being a positive number, it could be 0. And the last option would be if it were negative, so b squared minus 4ac could be less than 0. So positive equal to 0 or less than 0. Now if we think back to the things on the first page, if you have a positive number, then when I'm in my quadratic formula I do negative b plus that square root of a positive will be a nice number, positive real number. So negative b plus the number divided by this gives you one answer. Negative b minus that real number divided by this gives you a different answer. So number of real roots we're going to have is going to be 2. So if we're looking at the picture, maybe I'll quick just throw in a XY graph in each of these. Nothing to be real proud of there, but then, so this one is going to be like that top one I had. And actually maybe I'll make mine open down, because your parabola could open down, it could straddle the y-axis in the part you can see, but the point is just that we have two different answers there and there. So in English, we have two x-intercepts. Maybe I'll actually put those in a different color just for emphasis. So one would be there, and one would be there, two places. If instead b squared minus 4ac equals 0, then if we go back to our quadratic formula, we have the square root of 0, which just is 0. So negative b plus 0 divided by this gives you one answer. Negative b minus 0 divided by that gives you the exact same number. So the number of real roots is just going to be 1. That's going to be the situation where your parabola, the vertex is on the x-axis. Could open up, could open down, but you're just going to have one spot where it touches. So then we have one x-intercept. And last solution, if b squared minus 4ac is a negative number, if it's less than 0, now once we get in here, once we do square root of a negative, we're back to an imaginary number. So we'll have a real number plus an imaginary divided by a number. It's kind of like when you divide, that we'd take and say, well, negative b, how do I want to write this? You'd end up with negative b over 2a is the real part. And then you'd have plus your certain number of I once you apply the radicals. Maybe we'll say 3I. But then you divided the 3 by 2a. So that would be one solution. The other solution then would be negative b over 2a minus 3 over 2a. If I lost you there, just go through, start the problem, and kind of work through it. But the point is, both of these are not going to be real. So you have 0 real roots. In English, there are no x-intercepts. So no x-intercepts. Or if you wanted to, you could write the graph, the parabola doesn't touch the x-axis. And for that one, I'm just going to draw a graph that's either all above or all below. Maybe I'll put it all above just for variety's sake. But it could be the other, that you don't have any place where it touches the x-axis. That rounds out the notes from Chapter 6.